Hi everybody, we are going to be doing geometry lesson 2.5 today, which is talking about angles and their relationships. So earlier we had talked about specific types of angles when we had crisscrossing lines. So the first thing that we're going to do, well, let me go back to the objectives here. I guess I should highlight that first. We want to be able to understand the relationships between special angles and then prove those relationships using deductive reasoning. All right, so review question number 1. We're looking at this figure that looks pretty familiar from last time. And we are looking for a pair of linear angles. So it says use the sketch to define a linear pair of angles. And remember, a linear pair shares a vertex and a side. Now, a linear pair has that word line in it, so you can kind of distinguish it because the two angles together will form a straight line. So some examples would be angle 1 and angle 4. Right, here's angle 1, here is angle 4. Together, they share this vertex point, and they have this common side. When I connect the other two sides together, it forms a nice straight line. And it kind of looks like a half circle, like a protractor. And so anytime you can make that protractor curve, highlighting the two angles, you can see that it does make that straight line. So that would be a linear pair. Now remember, a linear pair is also supplementary. So the two angles together add up to 180 as well. All right, now here is our linear pair conjecture, which basically is all that we talked about before, but putting it into a formal statement. So from your sketch and definition, complete this conjecture about the total measure of both angles together. And we had already talked about that. Because they're forming that straight line, they are forming a supplementary pair. So if two angles form a linear pair, then they are supplementary, which means they total 180 degrees. So let's name all of the linear pairs. Up above, I had already named one of them, angles 1 and 4. But I'm looking for the remaining linear pairs. So did you guess these? Angles 1 and 2. They form a straight line, making that protractor-like figure. Angles 2 and 3. They form a straight line, making that protractor-like figure. And angles 3 and 4. Those are all the linear pairs. All right, review number 2, vertical angles. Remember that word vertical does not mean up and down. So to be a vertical angle, they have to share a vertex, but they do not share a common side. And position-wise, again, that vertical, it's not meaning up and down, but rather they're kind of across from each other. So in this example, angle 1 and angle 3 would be an example of vertical angles. So here you can see angle 1 and angle 3. They both come together at that same vertex right there in blue, but none of their sides, the red or the green sides, are overlapping each other, and they are across from each other. So which pairs of angles are vertical angles? 1 and 3. What is the other pair of vertical angles from this picture? 2 and 4. Okay, now the new piece of information, the vertical angles conjecture, actually says because those angles are vertical angles, they are identical in size or equal in measure. So if I go back up to that picture and I wanted to show that they were equal in measure, I could put the hash marks showing that 1 and 3 are the same and angles 4 and 2 are the same. Now we're going to use deductive reasoning to prove that is the case. Okay, now in order to prove that this is correct, I can't use specific numbers because that would only be proving that one example. However, I do want to use the fact that we are understanding the linear pair conjecture. So remember, the linear pair conjecture states that if we have a linear pair of angles, such as angles 1 and 2 here, they add up to 180 degrees. So I'm going to use that information to show that an example of vertical angles like 2 and 4 will be the same size. So angle 1 plus angle 2 equals 180 degrees. They are a linear pair. Well, that's also the same with angle 1 and angle 4. They are also a linear pair, adding up to 180 degrees. Now, if I look at these two statements here, the common between them is angle 1. And so because these two angle 1s are identical in size, it does imply that angle 2 and angle 4 have to be equal. And angle 2 and angle 4 are vertical angles. So right here, because of the linear pair conjecture, we were able to state that vertical angles are always congruent to each other. Okay, many conjectures are written as if-then statements. And when we take an if-then statement and we reverse it, it's called the converse. So the converse means to switch around the if-then parts of a conjecture. So here's our original statement. It says if two angles, so here's the if part, are a linear pair, then they are supplementary. And so we need to write the converse of the statement by switching the if-then parts. However, if we just flip-flop it, it's not going to be grammatically correct. So we have to be careful. We still want the if and then where they're located. And we're still talking about two angles. So I'm still going to say if two angles, and this is where I switch the parts around, are supplementary. Then they form a linear pair, or they are a linear pair. Now, just because I wrote the converse of a conjecture that we have, it does not mean that the converse is necessarily true. So if you notice down here, it says original statements that are true can produce converse statements that are true or that are false. They do not need to have the same outcome. So this first statement, the original, it says if they're a linear pair, which would be something like this, angles 1 and 2, then they are supplementary. And that is a true statement because it makes that half circle, which equals 180 degrees, like the protractor. However, if two angles are supplementary, they do not have to be a linear pair. For example, I could have two separate angles, ones that are not touching each other, not sharing a vertex or a side. They are still supplementary but they are not a linear pair. So this is a false statement. All right, now we're going to practice using some of our angle skills here. We have quite a few vertical and linear pairs in this diagram, and we need to solve for the missing angles, explaining how we found each one. Now, there's different ways to approach every problem. It just depends on what you see visually in the example. So I notice right away that I have two crisscrossing lines here. And those two crisscrossing lines are creating four separate angles. Those four separate angles are all sharing the same vertex. So that means I have some linear pairs and some vertical angles. Now remember, vertical angles are the exact same size. So in this example, 45, which is vertical with angle B, would be congruent. So angle B would also be 45 degrees. So down here, angle B equals 45 degrees because it is a vertical angle with the given 45 that was there. Now if I look at angle C or angle A, they are not vertical with the 45 because they are sharing a side. But if you notice, they create that protractor shape together. So they are a linear pair or supplementary, which means they have to add up to 180 degrees total. So I need to take 180 and subtract off the 45 to find angle C. And this gets me 135 degrees for angle C. Now I can do the same thing for angle A. However, angle A is a vertical angle with angle C. So that means my measurement for C is going to be the same size as the measurement for A. So down here, angle C and A are both 135 degrees because they are a linear pair with the given 45 that was there. We could also say that they are supplementary because all linear pairs are supplementary. Okay, I would like you to try solving for D, E, and F. All right, this is the results. Letter E is a vertical angle with 70, so they are equal. D and E together are a linear pair, or they are supplementary. So this one has to be 110 in order for a total of 180 to happen. D and F are vertical angles, so they are the same, 110. Okay, now I would like you to try solving for G, H, and I. All right, again, a vertical angle with the 65 would be angle H. So this one would also be 65 degrees. H and G are a linear pair. They make that half protractor, or that half circle that looks like a protractor. So they have to add up to 180 degrees. If I take that 180 and subtract off the 65, I get 115 degrees left over for G, which means that I is also 115 degrees because it is a vertical angle with angle G. So you can use that information to fill out your notes here. And finally, we have our summary for these notes. So we will complete this as a recap of this material.